Geology of Glacier National Park by Connor and Jacob. Hello everyone, my name is Jacob.
My name's Connor.
We will be talking to you about the greatest national park in America, Glacier National Park. There are many different aspects to the park that make it so great. Glacier National Park is the United States' 10th national park and has welcomed over 100 million visitors.
What are your favorite parts of Glacier National Park?
Well, some of my favorite parts are the beautiful mountains, vast plains, and Lake McDonald. There are a lot of different hikes and sights you can see while visiting the park, as well as many wildlife.
The park holds over 700 miles of hiking trails, so much to see. It is also part of the world's first international peace park, and human use can be dated back to 12,000 years ago.
However, none of these beautiful locations would be possible without geology, our main focus for today. The timeline of the geology of Glacier National Park is truly amazing.
Today we'll talk to you about some of the tectonic and volcanic activity that has affected the park in the past, as well as shaped it into what it is today.
To understand how the mountains of Glacier National Park have formed, we need to look at what kind of rocks make up the park. Do you know what kind of rocks make up the park?
Well, I know that igneous rocks make up part of Glacier National Park, but I'm not so sure about any others. Could you give me a hint?
You're right about the igneous rocks, but the other type of rock you're forgetting is sedimentary rock.
Could you tell me a little bit more about sedimentary rocks?
Sure, sedimentary rocks form when layers of sediments, debris, and other minerals and materials lay down in layers over millions of years. The difference in these layers are formed due to the change in the environment of Earth. For example, the sediments in Glacier National Park show signs of ripple marks made by the waves of a beach, hinting towards there previously being a large lake or sea that deposited them. I'm not really sure which sedimentary rocks form in Glacier National Park, though.
I know that. The sedimentary rocks found in Glacier National Park include sandstone, shale, and limestone. Shale and sandstone are classic rocks, while limestone is a chemical sedimentary rock formed from cemented organic material, typically fossils.
So cool. What do you know about the igneous rocks?
I know they have formed from cooling magma. In Glacier National Park, diabase forms between the sedimentary layers. Diabase is an intrusive igneous rock, meaning the minerals are much larger and visible inside the rocks. Since diabase was extremely hot, it also turned the surrounding limestone into marble through contact metamorphism. This forms the diorite still.
Next up, we have tectonic activity. The type of boundary that helped form the park is called a convergent continental tectonic plate boundary.
I've heard of convergent continental plate boundaries. I've also heard of continental oceanic convergent, divergent, transform boundaries. How do these compare?
Well, a continental plate boundary is when two continental plates collide, causing the land to be lifted up in the air, while a continental oceanic convergent boundary involves the oceanic plate going beneath or subducting below the continental plate.
What's a divergent plate boundary and transform plate boundary then?
A divergent boundary is when two plates move away from each other, and a transform boundary is when two plates slide past each other, causing earthquakes.
So the continental convergent boundary caused the pre-existing sedimentary rock on top of the plate to be pushed upward?
Yep, this is a process known as uplifting. This activity formed the main mountains of Glacier National Park and how those tectonic activities have impacted the park overall.
Lastly, glaciers have helped to form the park. The water from the ice has helped in the process of chemical weathering, where its ions bond with the sediments and cause the rock to break down.
Glaciers will also erode the landscape by pushing smaller sections of rock out of the way and leaving larger sections behind, which help carve mountains. This has had a huge effect on the landscape of the park, leaving behind U-shaped valleys, hanging valleys, and moraines.
Glaciers can also have negative effects on the park. Loss of glacier meltwater can cause the extinction of several temperature-sensitive insects.
The glaciation and topography also makes the park prone to debris flows, a form of erosion where large masses of dirt and sediments erode away.
We hope that learning more about Glacier National Park's unique formation story has helped spark an interest in learning more about the park.
Only time will tell how the glaciation and weather continue to form the park in the future.